Hey Jarvis, look at the camera and tell me what I can build with the things you see.
You have the makings of a basic automation or remote control system. With the microcontroller and relays, you could construct a device to switch appliances or lights. Perhaps something to remotely brew coffee, given your laptop's urgent plea.
Turn on the tube light and open Spotify on laptop.
TubeLite Online. Opening Spotify.
Open Spotify and look up F1 timings and tell me about the 2026 F1 season.
Opening Spotify. Searching the web for F1 timings. The 2026 Formula One season will introduce significantly revised power unit regulations, prioritizing sustainable fuels and a substantial increase in electrical power deployment. This mandates a new engine architecture promising both enhanced relevance for road car technology and a considerable re-evaluation of aerodynamic design. One anticipates the usual scramble for performance, with an added layer of electrical complexity.
Hello friends, welcome back to another video on this channel. In today's video, I will tell you guys about the Jarvis home automation system I just built and I showed you guys. So the way this system is working is actually basically what I have here is a local computer. So I have my PC running a couple of local models along with Gemini to control everything around the house. So the way this works is, first of all, we have a model called open wake word. Now this open wake word model is basically, all it does is it checks for a specific keyword. So in this case it's obviously hey Jarvis. So what it does is, now as you can see here, when I call the name, it turns on. So the thing is, the way that works is, as soon as I say that command, that word, right, I'll just stop it here because it'll keep using my Gemini credits for no reason. But yeah, I'll just put a yeah. See, so basically what I'm doing here is, it is a open wake word model. So that model basically, now this is obviously stopped as you can see here because all the three have gone red. I'll turn it on again and show it to you guys as well. But basically that model just looks for a keyword, which in this case was hey Jarvis. As soon as that keyword is said, it will wake up, and what it does is it starts recording everything after, as soon as that keyword is said, and then it sends it to a model called whisper v3, whisper large v3. So basically this model, the model is whisper and the version of it is large v3. Now this large v3 is actually quite a large model, and for this you need a proper GPU, because I tried running this on my CPU but it was not running. And this is a pretty decent computer as well. It's a proper gaming PC. This has a like a 6 core AMD and a, I think it's a 3050 on this. So it couldn't run it on my 6 core AMD, so I have to run it on my Nvidia GPU. Now the thing is, another thing is, you do have to run Ubuntu for this, because this just doesn't want to work in Windows either because of permissions and stuff. As well as, I mean, Windows is already bloated and this is already running quite like, this is quite heavy on the GPU as it is on the 6 GB GPU. So you can understand, with Windows running in the background, it's obviously a lot more like a lot less responsive basically. Now basically this model, the large whisper v3, all it does is it's converting my voice into text, right, and it makes it a transcript, which is then passed on further to a heuristic parser, which all it does is basically, it's like making a vector of the voice, and it can like compares it with a few specific commands we have already set, because there's only a few commands you are going to use locally, right? Things like turn on the fan or turn off the fan. Now obviously this won't work because I closed the whole system. um so like the way now the fans and stuff is working is also quite intuitive. Basically what I have is an ESP32 connected on my Wi-Fi, home Wi-Fi. Now the way that works is, I have the ESP32 runs a HTML web page. Now the reason I did it this way instead of WebSockets for most people is because, see, now if I go over here, I can actually go on to my ESP32 directly. See, even though the system is off, I can access my ESP32 directly and I can use it. So this way I can use it from my phone or anything I want without using Jarvis directly, or I can use it via Jarvis as well. So that HTML page you just saw, that is a website which is being hosted on the ESP32 locally on my network. Now it exposes a few key APIs. The way that works is, first of all, there's a status API. So that will give you the current status of all the devices on it. So this stays fresh even if I turn on or off something from my other phones. And then it has a slash, like basically a command to set the things. So slash set, I think, is the command actually, which will turn on or off these, and then it will then update the slash status to reflect that, and actually obviously turn on or off the actual relays. Now obviously that's just a smart switch. It's just literally a ESP32 connected to a relay which is in parallel to all the other switches, right? So it's just a simple system, but integrated with this it becomes quite a powerful tool, because now from anywhere around the house I can just call Jarvis. And then, because if I have multiple microphones, right, which is not a complicated thing to set up, you can have multiple microphones, and then just anywhere around the house I can call hey Jarvis, and then I can turn on or off the things. And then for the other things you just saw, right, so the most important and the most complicated thing which I had to deal with was, of course, the image system. Even, see, the thing is, what happens when we are trying to do the image, right, because this computer doesn't have a webcam and I didn't want to use a wired webcam either. What I wanted to do was use my phone on a wireless network. So what I have running on my phone is an app called IP Webcam. It's an app you can find on Google Play Store. It looks like this. This is an app called IP Webcam. Now what this does is it basically starts an HTML server on your website, on your Wi-Fi. And as you can see down here, it shows you the IPv4 address of it. So you can connect to this directly and use its APIs. So we are using a /getImage API to basically just click a frame and get that frame. And then what I do is I simply send it to Gemini along with a very specific prompt to get through the image and figure out what's going on and send it back. So that was obviously getting those API keys to work, API calls to work properly was a complicated thing to do. And I'm not obviously going to be able to cover everything in detail what I did. This is just a showcase mostly, because this is quite a long technical project, and if I had to tell you about everything I did, the video would go on for hours. So I'm just going over overview of everything that I did, right? And now the next thing is, so what we are doing is, for voice there's a model called Piper. That is the thing that actually speaks out like whatever the text is. So that's the speech as well. So when Gemini returns a answer, or for example when a local heuristic parser is done with a command, let's say tube light powers down or something, and then that'll be a specific hard-coded command for most of these, and then that is what is sent to Piper, which will read it out as a voice. Now I also set it to a Jarvis voice, Jarvis-esque voice, but you can set it to whatever you want, and that's what is actually speaking it out, right? Other things like the window controls you just saw, like open Spotify on both this PC, and this is able to control other computers on the network as well. So the way that works is simple. The other computer runs a small program which again exposes it to HTML to any computer on the network, but because obviously this is actually able to run commands as well. Like I can actually use a command prompt, run commands on it, like delete or whatever I want to do, or open apps वगैरह. But the open apps is fine, but the commands is obviously a security risk. So this has a specific token. When you set it up on the new PC, which I'll show you in a second, it actually has a token on it for a new PC. As you can see here, the PC agent token. So this token you have to set, and this has to be same on both the .envs. Otherwise this whole system will not be working because it needs the tokens to match. Only then will it be able to send commands to the other system. Now another thing is the Gemini keys, right? So Gemini, we are using the free model because obviously if there is a free one you want to use it. But the thing is, the Gemini free models are very like they run out of limits very quickly, right? So what I came up with was actually a pretty clever Gemini rotation system. So as you can see very carefully, this says keys, not key. So if you are using a single Gemini key, you paste it here. The other keys for other accounts, because you can create multiple free Google accounts and then get multiple keys. So what this does is it basically has a clever key rotation system. So it will keep checking each key, and so you can have like 5-6 keys on this system, and at one point any of the keys, if any of the keys work, which it is basically bound to work, right, one of the keys of 5, then it will use that one and wait for the others to for the limits to reset. So that way, basically, even though I'm using a free model, I'm pretty much almost always gonna have keys like tokens left, because there's so many accounts split across. So yeah, that's basically the gist of it. Oh yeah, there's also, this is also able to control like other windows as well. Like it can open and focus on windows. So it uses GNOME for that. Like it's a thing on Ubuntu which allows you to basically control windows directly. Like you can control which window is open, which window is on focus. You can do like sideways windows and stuff like that, like side by side windows and whatnot. Yeah, that is what the tool we are using for controlling the windows on this. As you saw, I told it to open Spotify on the laptop and open Spotify separately on this. So open Spotify on the laptop was on the laptop, which is not connected by any way other than Wi-Fi. It's just on the same Wi-Fi network. That's it. So yeah, that's basically it. Now, for now, it's just locally hosted on a website, because I didn't feel like there was a need to make it into a proper app or anything like that, because it just doesn't make sense for this scale. Other things which are pretty cool, this is actually working. This is your readout for CPU memory, how much load it has, vagera vagera. This thermals is not working on this, because I don't know why on this computer it's not working. It's working on my other one, like my laptop, but for some reason it's not working on this computer. I don't know. And this is network telemetry. This is live network telemetry, but of course now it's not gonna show because this is off. This is environment. This is actually a live environment. It pulls it from weather.com. But the thing is, this space, this is actually my college Bits Pilani location. Like I didn't set it to get the location from the computer, because that's a lot of permissions you have to get, and like just didn't want to deal with that, so I just hard coded this. So you can change that in the .env as well to wherever you are to get the place's location. This voice activity, this actual graph is just more of a representation than actually what is happening. This just is basically volume that makes all these go up and down, and this is important. This is the the open wake word thing. So the way this works is basically there's a threshold you can set an open wake word. Right now I have it set to 0.5. You can lower that or increase that based on your specific environment conditions. I found that 0.5 is ideal for me because it has the least false wake ups, but it always reliably wakes up whenever I say the command. So this you have to check a bit what every time you just say it a few times, it will show you what amount it went to. So whatever is the highest, it's going to reliably every time. You just set that as your threshold. Yeah, that's basically it's like that's basically it for this system. Now I'll show you how to install it on a new computer as well. So over here, this is my laptop, by the way. This monitor is connected to my PC. As you can see, it's Ubuntu, and this one is Windows. Now the way it was controlling was obviously on Windows, as you saw. So the thing is, now when you go to my GitHub and download this, you can get this from my GitHub. All you have to do is obviously copy .env.example into .env, put in your specific IP for ESP32 and all that. I'll set the ESP32 code as well, the Arduino IDE files as well in the GitHub separately. Yeah, this doesn't have it currently in this folder, but I'll just put it and then push to GitHub as well. All you have to do is change the token. I mean, you cannot change the token as well if you're on a local private network like your home network, to be honest. But anyway, it's better if you do. Then you have to find and change your laptop IP, the IP of the Windows computer you want Jarvis to control, right? So the way I did it is I just set up a permanent IP address for this on my router. You can just go to a router's administration page and set up permanent IP addresses for this, because what happens is usually when you restart your router or restart the computer or like basically rejoin the network, or even in most routers, there is a point where IP addresses keep changing every so often. So obviously you will have to change it in the .env every time. So the better idea is to just set it once, and then obviously, as I said, Gemini keys, you have to get your own and put it here. This you don't need to change. This is just something where you will go to and find it out. Now obviously these are the other words. So open wake word is the model we are using for wake. Then the speech to text is whisper large v3 running on CUDA. There's 0.5, which is the threshold, which you can change. This is basically for converting it back to voice. So we are using audio play, PW Play as the audio play. Now none of this is for Windows. This is on my Windows because I just downloaded it. But obviously this is all gonna be running only on Ubuntu, not on Windows. Oh yeah, phone camera URL. This, as I showed, it says an IP address on the app, IP webcam app, right? So just put that IP address, and now again I'd recommend putting your phone as well on a constant IP address from your router's page, so this doesn't change as well. Yeah, that's basically it for .env setup. And then all you have to do is just run this /run setup new pc.sh. This will download all the dependencies and everything you need to do. Even it even actually downloads the actual GitHub. Like, it'll check for the version, get the latest one, download all the pipers, every model you need. It'll run all the tests. It will download every single dependency it needs, all the packages, everything it needs. It will be downloaded directly from this one command. It will even create a .env and fill the things from the basic. You have to obviously fill this yourself, right? But like this one, it will copy and create everything, so you can directly use it directly. Like, all you have to do is fill the .env after running this. And then to run the actual model, you have to run this one /run jarvis.sh. This one will kill any of the past instances that might be running, create new ones, and then it will basically just start the full server, including the voice. Now you can separately run as well. Npm start will open, create, like, it'll start the actual orchestrator, everything but the voice, and /run voice -full is the one. So in deploy, you can see here, orchestrator services, this one you can run. This one will basically just install npm, and it will run your npm, which is what the main server is running on. This doesn't have everything but the voice. And then voice service is what will run the actual Jarvis voice service. So all the models will start running. So voice, both to speech and text to speech, as well as speech to text. So both of them will be running simultaneously. Both of them run together. Like, if one of them is not running, both of them won't work. So if you don't want voice, you can type a command. Obviously, as you see here down here, there is an option to type a command as well. You can type the command, but in that case, the voice to speech won't work as well. Sorry, the text to speech won't work, so it won't speak as well. Yeah, that's basically it for this project. I hope you guys enjoyed this video. If you have any doubts, please leave it in the comment section, or you can make a new issues in the GitHub repo as well. Yeah, I'll see you guys next time. Thank you so much for watching.